Whenever we are learning to find and exploit or prevent different types of vulnerabilities, we always want to understand its root causes and what actually happens to an application when the vulnerability is being exploited. So today, let's talk about a very common vulnerability, sensitive information leaks, and how you can spot it in an application via data flows. Sensitive information leaks or sensitive data leaks are a very common issue in applications. It's basically whenever a piece of sensitive data gets into the hands of people who should not be able to read that data. So, for example, when an application writes personal data like credit card numbers into application logs, then the administrators or the security incident responders who have access to those logs will also get access to those credit card numbers, which is something that you obviously don't want. Or if the application writes sensitive information like API keys or an encryption key onto a web page, then anyone who views that web page can get access to that information as well. And so, how do you exactly spot this behavior in an application? And so, before we go on, there are a few concepts that you should probably understand in order to conduct a source code review effectively. The concepts are sources, sinks, and data flow. In code analysis, a source is the code that allows a vulnerability to happen, whereas a sink is where a vulnerability actually happens. So take command injection vulnerabilities, for example. A source in this case would be a function that takes in user input, whereas a sink would be functions that execute system commands. And if untrusted user input can get from the source to the sink without proper sanitization or validation, then there is a command injection vulnerability in that application. And many common vulnerabilities can actually be identified by tracking this data flow from appropriate sources to their corresponding sinks. So we're going to fire up the analysis tool that we're going to be using today called Ocular real fast. And then import the project that we are analyzing. We will be analyzing a Java project called Target Java, and we will be feeding a WAR file into Ocular to be analyzed. And after I imported the project, I like to run a command to make sure that I have the project properly loaded. And I typically run the query cpg.method.name.l for this purpose. This command will look for all the methods defined in the project, extract their names, and then list them. So this is essentially a query that tells Ocular to list all the method names in the project. With Ocular, you can also list all the identifiers in the application instead. So this means things like local variables, globals, and class members. Let's start by looking for the sources of a sensitive data leak. Let's say that we are looking for user order information leaking into application logs. And we know that our application stores user order information, including the user's credit card information, in an object of the type order. So we can find all the identifiers of the type order by filtering the identifiers by their type name. This will find us all the identifiers that point to order objects, which we know store user information. And we'll define this as the source of the vulnerability. Next up, let's take a look at sink functions for sensitive data leaks. We are looking for places where this order information is being actively leaked into logs, right? And we know that our application is using the info method in the logger class to log information. So we can look for all the calls to the info method. And since we are interested in tracing identifiers being passed in as the arguments of the info method, we will add arguments here. And then finally, we can tell Ocular, show me all the places where a source can reach a sink in terms of data flow, and then pretty print the results. you'll see a list of data flows where any identifiers of the type order are written into log. And you can see here that one of our results show that one of the places where order information is written into logs is on line 83 in the file named orderstatus.java.